Hello, my dearest friends and friend. Welcome back to my new lecture. And again, we will be discussing environmental pollution and its types: air pollution, water, land, measure to control and mitigation. Under this, today we'll be discussing the large dam and its impact on environment. So, I'm Professor Urus Ilyas, working in Department of Wildlife Sciences, Aligarh Muslim University, and we'll be discussing this sixth week course, lecture number 27. What are the large dams? What are the dams? Dams are made to to control the flow of the water. Okay, and these dams give us the electricity also. So they are typically defined as structure over 15 meters tall or those with reservoir exceeding 3 million cubic meter in capacity. These dams are built to store large volume of water for irrigation, hydropower generation, flood control, and domestic as well as industrial use. They require complex engineering, advanced constructions material, and represent a significant capital investment, reflecting their pivotal role in regional water management and energy infrastructure. So, definition and criteria: typically dam taller than 15 meters or with a reservoir over 3 million cubic meters, store large volume of water for multifaceted uses, key function, irrigation, hydropower, flood control, water supply, and recreation. Global context: thousands of large dams exist worldwide. Significant examples are found in India, China, and the US. We have Bakra Nangal Dam, we have Rihan Dam. So many dams we have. And technical aspects: construction involves complex engineering, advanced material, and significant capital investments. It's not easy to make the dams. Making the dams, you have to take approval, you have to satisfy the query of the people, and then only you can approval and site selection, proper management. These it's involved lots of, and it takes years and years to make one dam. So, benefits and functions of the large dams. Large dam brings with them several critical benefits. They provide reliable water storage for agriculture, domestic consumption, and industrial use, especially during drought period. They generate renewable hydropower that contribute sustainably to nation energy grid, helping reduce or reliance on fossil fuels. Additionally, these structures assist in flood control, protecting downstream communities by regulating river flow. Beyond these, reservoirs created by dams often become hubs for recreational activities and local tourism, fostering economic development. So we can see the map, the diagram: hydroelectric power. It's through the with the forceful flow of the water we get the energy. So, benefits and functions of large dam: water storage and supply, provide water for agricultural, drinking, and industrial use, help in weathering drought condition. Hydropower generation, offer renewable energy that help reduce reliance on fossil fuel, contribute significantly to national electricity grid. Flood control, regulates river flow and reduce the risk of downstream flooding, protects urban and rural communities from seasonal flood events. Recreation and economic development: reservoir develop into sites for tourism, fishing, boating activities, and stimulates local economy through job creation and infrastructure development. So, this is about the benefits and the function of the large dams. And environmental concern overview. Despite their benefits, large dams come with considerable environmental concern. They alter natural river flow, changes sediment transport pattern, and can significantly modify water quality and temperature. These alteration may favor certain species over other and lead to ecological imbalance. So overall, while dams help manage water resources, they introduce complex ecological traits of that must be carefully considered. Key environmental issues: disruption in natural river flow affecting water quality, alteration of sediment transport resulting in an upstream and downstream challenges, changes in thermal region leading to temperature shift in water bodies, and trade-offs are the balancing the benefit of managed water resource with ecological damages. Reorganizing an engineered solution often comes with the constructor uh, unintended ecological consequences. Impact on river system. Yes, if we are making the dam, there is a big impact on the river system, because we are not only stopping the water but also changing the direction of the water and the flow, the animals flow. We are also controlling their way. So flow alteration, natural flow cycle are modified, which influence spawning, migration and feeding pattern of aquatic species. Sediment retention, trapping of sediments, reduce nutrient flow downstream, impacting agriculture and delta formation. Water quality challenges are stagnation in reservoir can lead to lower dissolved oxygen level and alter pH level. Ecosystem fragmentation, physical barrier interrupt not only flow but also connectivity between aquatic habitat. Impact on biodiversity, uh, advancing ecological civilization. Impact on biodiversity, obviously if you are stopping the flow of the water, changing the direction, there will be impact on the aquatic flora and fauna. Habitat submergence is one of the critical challenges posed by large dams. The creation of reservoir typically flood extensive areas, submerge forests, wetlands, and wildlife corridors. This process disrupts the natural migration pattern of fishes and other aquatic species, often lead to the decline of endemic species that depends on connectivity within the river network. In turn, these disruption can alter the entire aquatic community, sometimes favoring invasive species over native ones, and impact on native ones. So we can discuss like this: habitat submergence. If you are making the land, lots of area or surrounding area will be submerged. We have to clear the area. We have to make the settlement with the villagers, shift the village different if that area is coming under the dam site. So large area of forest, wetlands and floodplains are inundated. Disruption of species migration, dam block natural migration route for fish and other aquatic life, and loss of endemic species. Unique species may face extinction when their specialized habitat are altered, and altered community dynamics, change in water chemistry and flow pattern can favor invasive species over native one. Impact on forest and land use. Deforestation, land degradation, soil erosion, and cultural and land use changes. These are the four impact the forest and land impacts on the forest and the land use. So deforestation, because when we are making the dam, we have to clear the large area with the forest. So large area are cleared to create reservoir, impacting local flora and fauna. Land degradation, submerged land lose their productivity capacity for agriculture and forestry. Soil erosion, exposure of newly created shoreline can lead to erosion and sedimentation problem. Cultural and land use changes, farmlands, tribal lands and area of historical significance are often permanently altered or lost. Greenhouse gas emission, definitely there are dams, there are development, there are greenhouse gas emission are also involved. Although large dams generate renewable energy reservoir can contribute to greenhouse gases emission. The decomposition of submerged vegetation produce methane, potent greenhouse gas. The effect is especially pronounced in tropical region where high biomass decomposition occur. This emission illustrates the complex climate consideration associated with dam construction and operation. So, highlighting that renewable energy projects can sometimes have unexpected environmental loss. So, methane production, regional variation, broader climate impact. Methane production, decomposition of submerged organic matter, release methane, a potent greenhouse gas. Regional variation, emission are particularly significant in typical reservoir due to high biomass decomposition and broader climate impact, while renewable hydropower reservoir can paradoxically contribute to greenhouse gas emission. There are social and cultural impact also, displacement of communities, livelihood disruption, cultural heritage loss, and community conflict. So these are the major four social and cultural impacts. Displacement of the community. So large dam projects have historically led to the forced resettlement of the millions, altering local demography. We have seen this in while recently Sardar Sarovar Dam was constructed, and because of that Meda Patkar was making lots of agitation, speaking in favor of the locals. They should not be displaced from the area, and these dams are not good. So displacement of the communities, displacement is not only leaving, but also you have to settle down in a new place, and you have to acclimatize, and you have to start everything from the beginning. So this is the displacement. So because of that, there are mental harassment also. So displacement of communities, livelihood disruption. Definitely when the community is shifting outside the range of the dam construction, they will be taking their livestock also along with them. So for them also it is difficult, because ages they are living there. And livelihood disruption, definitely if they are doing something like traditional agriculture communities, fisheries, and indigenous people often lose their primary source of income. We are basically farmers and hunter gatherers. So, dependent on the agricultural land, dependent on the flora and fauna for our livelihood. So, if you are leaving the place, means livelihood disruption is also there. Cultural heritage loss, submerging cultural, historical, or sacred sites cause irreversible loss of heritage. Community conflicts, resettlement, and compensation issues can help to social unrest and long-term community challenges. So this is the social and cultural impact. There are case studies with detained inside. So let's examine a few case study. The Sardar Sarovar Dam in India, and the Gorge Dam, China, and additional examples. So Sardar Sarovar Dam in India offer critical water supply and power. However, it has led a significant displacement, ecological shift, and cultural loss. Long-term impact include altered river hydrology in the Narmada basin. Three Gorge Dam, that is in the China, illustrate the sheer scale of hydropower and flood management benefits, counterbalanced by massive ecological disruption and sedimentation issue. Has triggered debates over seismic safety and environmental sustainability. Additional examples are the Terry Dam and Hoover Dam in USA, each with its own set of ecological challenges and community impact, highlighting the complexity of large dam project. So these Sardar Sarovar Dam in India has provided critical water and power resource, yet it has also resulted in significant displacement and altered river hydrology. And in Narmada Basin, Narmada Basin, the Three Gorge Dam in China is primarily example of the massive hydropower potential, yet it has also triggered serious concern over ecological disruption and sedimentation. And additionally, projects like the Terry Dam in India and even historical projects like the Hoover Dam in USA highlight the complexity of the trade offs and comes with such large scale infrastructure. So, migration and sustainable practices, environmental impact assessment, fish passage technologies, sedimentation management, and rehabilitation measure. So, environmental impact assessment, rigorous pre-construction studies to identify potential ecological and social impact, installation of fish ladder and bypass channels to restore natural migration route. There are lots of even the hillside is also suffering, which is a very popular fish item in West Bengal, in Calcutta. So installation of fish ladders and bypass channels to restore natural migration routes. Sedimentation management technique such as sediment flushing and bypass system to maintain nutrient flow, and rehabilitation measure, compensatory afforestation, riverbank restoration projects, and community based conservation initiative. So, mitigation and sustainable practices are environmental impact assessment. We have to go for the EIA, fish passage technology, and we have to take care of the passage of the fish so that their migration should not be affected. Sedimentation management techniques such as sediment flushing and bypass system to maintain nutrient flow, and finally rehabilitation measure, compensatory afforestation, riverbank restoration projects, and community-based conservation initiative should be there for the mitigation and sustainable practices. Alternative to large dams are small scale and runoff river dams. There are alternative of the large dams, small scale and runoff river dams, less invasive and designed to have lower ecological footprints while providing local water management benefits. Decentralized water solution, rainwater harvesting, groundwater recharge, and community management reservoir. Integrated watershed management, holistic approach that emphasize conservation, restoration, and sustainable water use without extensive dam construction. Conclusion and discussion. uh, in conclusion, while large dams play a critical role in water resource management and energy generation, they carry significant environmental, social, and cultural cost. Our challenge is to strike a balance between harnessing their benefits and mitigation their negative impacts. So, large dams offer significant benefits for water management and energy production, but come with equally large environmental, social, and cultural costs. A balanced approach with a robust mitigation measure and exploration of alternatives is critical for sustainable development. So, considering the trade off, how can future project better optimize dam benefits while minimizing environmental and social impacts? So, I invite you all to consider these trade offs and share your thoughts on how future water management projects might better integrate environmental sustainability and social equity. So we have to think over, instead of even the US, we are still going on. We are still making the big dams. Like one project is going on, river interlinking of the two rivers, the Betwa, Kane and Betwa in MP, in UP and MP. Bundel to provide the water to Bundelkhand region, and for that two rivers are being interlinked, the cane of, and under this there will be a big project of making the big dams. So these dams will not only okay, fine, they will be giving us the water and the electricity, but in return we will be compromising a big area of Panna Tiger Reserve, for which government has invested crores and crores of rupees to reintroduce the tiger. So that area will also be submerged because of making of the large dams, because of the interlinking of the water. So we have to think about it, and we have to find the alternative way, what we can do, because countries like USA is also discouraging the large dams. Instead of making the large dam, they are encouraging for the small dams, because large dams are fine, but when they are damaged, they are broke, the surrounding area for kilometers are submerged, and it's a big issue. So let's start thinking about this. We should find the alternative for these large dams. So thank you very much. These are the references I have used while making the slides. World Commission on Dams and Development, a new framework for decision making. Earth Scan. You go through this paper, this book, and it will give you the good insight of the dam. So thank you very much. We'll be meeting you in our next class. Till then, enjoy my lecture. ठीक है, थैंक यू।